All right, so here's 5.5, solve exponential equations. And I gave you some steps that I want you to follow. Let me write them down here again for you. So the very first thing I do is I isolate the exponential term. Okay, the value that has the exponent is called the exponential term. I always isolate that guy first. At this level, most of the time, the exponential term will already be isolated for you. Sometimes you have to do one little subtraction or addition, but our goal is to always get the exponential term isolated if it is not already isolated. And then I said, please remember the rules of exponent that we cover in 5.1. Anything to the 0 power is 1. And also, the most important one, so I'm going to put 2 stars, is I can turn a negative exponent into a positive exponent by writing as a denominator. Okay? But I also can go backwards. Okay? And that's what I told the students. If something is written like this, right here, 1 over x to the a, I can go backwards and write it as a negative exponent. We can move forward, but we can also move it backwards. Okay? So that's what I want you to understand it. Let me write an example here really quick for you before we can be good at solving equations. If I have 1 over 9, okay, before I get to 1 over 9, if I have 3 to the negative 2 power, I can write that as 1 over 3 squared. I bring this down to the denominator with the positive exponent. So this is negative exponent, and I can rewrite it with a positive exponent. I just did it. And then I can clean this up and say, well, this is the same as 1 over 3 squared is 9. So 3 to the negative 2 is 1 over 9. So if I just did this forward, I can also do it backwards. Okay? If you give me 1 over 9, I know that 1 over 9 is 1 over 3 squared. I'm just working backwards right here. And if I want to bring this 3 squared to the top and write it as a numerator, if I want to take it to the top, then I have to write it as a negative exponent and write it as 3 to the negative 2. Okay, so I'm showing you that we can work backwards and write it 3 to the negative 2, or if you give me 3 to the negative 2, I can turn it into 1 over 9. Okay, and we practice this a lot, and if you're having a hard time with this, we can practice some more in the math lab until you get it. Okay? So you have to have these skills in order to be successful here in solving equations. I'm going to do a few of them. I don't know how many will be able to do it, but I'll try to do a few of them in the next few minutes. And one of the things about exponential equations is that you also have to write things with the same base. I should have written that here in our steps. Besides isolating the exponential term and also using these 2 rules, another important thing is write the equations with the same base on both sides of the equation. All right, so we must write the same base on both sides so we can compare the exponents. Okay, I gave you all those steps in class. I'm just going to use it here as we're doing it. So let's start with number 1 first. It says 3 to the x power equals 27, and we're solving for x. Solve each exponential equation. We should say solve for x. That's the exponent. So I need to isolate the exponential term, which is already isolated. So I really don't have to do anything to the exponential term is already isolated. I like to write it big. This is too small for me. 3 to the x, I'm losing my sight. There we go. Right? So since 3 to the x is already isolated, I don't need to do anything else. Now I need to write this side with a base of 3. So this side stays at 3 to the x. I need to think about, or in my calculator, play with the number 3 until I get 27. And I know that 3 times 3 times 3 is 27. So 3 to the 3rd power, because I did it 3 times, is 27. Now, because we have the same exact base, the exponents must be equal to each other. Okay? So x equals 3. That's how we solve exponential equations. So notice I made the base, made same base Once we make the same base, the exponents, we can set it equal to each other, and that's true. Okay? And you can check it. Can x over here be 3? Does 3 cubed equals 27? Yes, it does. Okay? Now let's try number 2. Okay, number 2 here says 5 to the x minus 1. 5 to the x minus 1 equals 25. All right, again, the exponential term is all by itself. I don't need to isolate it, but I need to write both sides with the same base. I cannot change this base. That's a 5. So 5 to the x minus 1. But I need to write 25 as a base of 5. We know that 5 times 5 is 25. So I can write 25 as 5 squared because I multiply it twice. So now that I have the same base, the exponents get set equal to each other. Okay, so now I have x minus 1 equals 2. That's where the equation comes from. Now I need to solve for x. Solve for x. If you add 1 to both sides, you get x equals 3, and there is your solution. Check it. Does it make sense to be 3? Because sometimes the students do something, they get an answer, they think they did it right. Let's plug it in 3 here. 3 minus 1 is 2. Is 5 to the second power, or 5 squared, 25? Yes, it works. Okay, so check to see if your answers make sense. Okay. All right, let's pick another one that's a little bit more difficult. Let's do number 3. Here we go. Number 3 says, whoops, right there. Number 3 says 1 over 64 equals 4 to the x power. So I need to bring this 64 to the top because I need to have everything on the same level, not to deal with fractions. But I can write 64 as a base of 4. Okay, so the hint is always on the other side of the equation here. I know that 64 is 4 to a certain power. Let's find out what. And you can totally use your calculator. Okay, if you don't have to guess it. So this is 1 over 4 to the x power. So let's see 64. I know that 4 times 4 is 16. And then when you multiply it by 4 again, you check in your calculator, you do get 64. So 3 times, that means it's 4 to the third power. So 64 is 4 to the third power. Now I need to bring that 4/3 to the top, to the numerator. The only way to do that is to write it as a negative exponent. So that's going to be 4 to the negative 3 power equals 4 to the x power. Now that we have the same base, I can set the exponents equal to each other. So x equals negative 3, we are done. Okay? X equals negative 3, you're done. And it makes sense. If you plug in a negative 3 here, then you have to write it as a denominator, and that becomes 1 over 64. So there we go. I'm going to do one more. Let's find a little bit more difficult problem. It's number 8 maybe, and then we'll do another one. So number 8 says, I know you can't see it very well here, let me rewrite it. Number 8 says 1/4 equals 2 and x to the x plus 2. Okay, so let me realign here on the camera. There we go. That's what number 8 says. 1/4 equals 2 to the x plus 2 power. I know that 4 is somehow a 2 to a certain power. We know that 4 is 2 times 2. So I can write this 1/4 as 1 over 2 squared, which equals 2 to the power of x plus 2. Now, if I want to bring this up to the numerator, I need to write it as a negative exponent. So this is going to be 2 to the negative 2 equals, this side is just 2 to the x plus 2. Now that we have the same base, we set the exponents equal to each other. X plus 2 equals negative 2. And then we just need to solve for x. Subtract 2 from both sides, we get x equals negative 4, and that is your answer. Okay, negative 4. Now check it. Okay, go back to the very, very beginning. If x is negative 4 plus 2 would be negative 2. And 2 to the negative 2, I would write it as a fraction, would be 1/4. Okay, 2 to the negative 2, I would write as a fraction, and it does equal 1/4. Okay, 1 over 4. So the whole rule of exponents, okay, negative exponents, write as a denominator as a positive exponent, or vice versa. We keep using it over and over and over. Okay, so it's a skill that you need to practice. So that is most of your solving equations. Let me see if I have time to do one more. I would love to do one more for you. Let's work on number 15. That looks kind of ugly. 1 over 49. Number 15. 1 over 49 equals 1 over 7 to the x power. So let me solve this one for you. It is number 15. Here we go. 1 over 49 equals 1 over 7x. Some students see it right away, okay? And I'm going to do it both ways. Some students see it this way, right here. They don't even turn things negative. They say 1 over 49 is 1 over 7 squared, because 49 is 7 squared. And this equal 1 over 7 to the x. If this fraction equals this fraction right here, then everything has to be the same. The numerator has to be the same, the base has to be the same, the exponent has to be the same. Therefore, since I have the same base, the exponents must be the same, so x equals 2. Okay? Some students see it right away, okay, without having to turn anything into negative exponents. All right? That is the easiest way to solve it. Now, if you want to bring things to the top, if you want to say, I want to bring that to the top and that to the top, that is a little bit more, you have to have that good skills. The 49 is 7 squared, but if I want to bring it to the top, I'm going to write it as 7 to the negative 2. And if I'm going to bring 7x to the top, then I have to bring it as 7 to the negative x. Now that the bases are the same, you set the exponents equal to each other. Negative x equals negative 2. You divide it by a negative 1 on both sides, so x can be by itself. X equals 2. So as you can see, both way works, but you have to use the skills correctly. If you want to bring it up to the top, you have to bring it as negative exponents. Okay? Or some people kept it that way, and it makes sense as well. All right? So good luck with 5.5. It's solving equations over and over and over until you are used to making the same base and comparing the exponents. All right? And then here, it says use the graph to find a solution for this situation over here. It's saying what should x be so this left side equals the right side. They graphed the exponential equation. They treated this one as y equals 4 to the x over 2. And then they treated the 16 as also a different equation, y equals 16. So this is your exponential graph. This is an exponential graph. And this is your linear graph. Okay? This is your linear graph. So they're saying use the graph to find the solution. So where do they... Okay, so where does the exponential graph meet the linear graph? They meet at 4, x equals 4. So x equals 4. That's where they meet, right here, 4, 16. So does x equals 4 makes this equation true? If I put 4 for x, 4 divided by 2 is 2. So 4, and then I put 4 divided by 2. Does 4 divided by 2 is 2, and is 4 squared 16? Yes, it works, okay? So you need to be able to tell the exponential function versus the linear function graphed together, and then find where these two equations meet. We have a question extremely similar like this in the review packet that we just did yesterday, and it's all about meeting two equations and where do they meet each other, okay? So hopefully this helps you to solve this worksheet, okay? So good luck. Come to Math Lab.